Now let's just continue this interesting session with our next speaker, Dr. Haizhou from the School of ICT at our university. Dr. Qi holds a PhD also in computer science from the University of York. And he also holds a master, he got his master degree of science in AI from the University of Edinburgh. He has worked at Lenovo, Amazon, and Tencent before joining Shenzhen Polytechnic University. Now he's actively engaged in modular neural networks and also reinforcement learning. He's also the author of several textbooks of our universities and also the mentor to award-winning student teams. Today, Dr. Qi will share on deep learning from academic research to industrial practice. Let's warmly welcome Dr. Qi.
It's a cute owl looking at everyone here, right? Okay. So, good morning, everyone. Today I'm going to talk about hello, everyone. Today I'm going to talk about deep learning from academia to industry practice. Right. So, I will share some of my own or personal experience because we know that most of you, maybe you don't have that much industry experience, so let's go through it. So this is the agenda of our my talk here. So here are 4 sections. First one is I'll briefly talk about my journey, and the second we will explore about the gaps between the academia and the industry. And then we go back to the talent expectation, and finally we have Q&A, right? So start with my journey. So here I made a timeline of my own experience. I was a graduate from Zhejiang University. I pursued a Bachelor of Engineering of Optoelectronics. So luckily you know that the founder of DeepSeek, we are in the same department. And then after that, I go to University of Edinburgh to pursue the artificial intelligence in the year of 2010. So it's like 15 years before, right? After graduate, I go to Lenovo and Amazon for, you can see it as a gap job, right? And finally, I applied for the PhD in computer science and doing research in natural language processing. After graduated from the University of York, I went to the Tencent. I don't know what any of you know that. Oh yeah, okay. So I went there to do AI application research, which is we were doing the recommendation system. I don't know any of you here use the app TikTok. Yeah. Okay. Red Note. No. Okay. Yeah. So actually, the recommendation system is everywhere around us. So all our daily lives are somehow affected by the recommendation system. And now, luckily, I'm a lecturer in Shenzhen Polytechnic University. Okay. So this is a brief timeline. So I would like to talk about my journey in academia. I don't know any of you here have ever experienced in academia. So my experience in academia mainly lies on the PhD study. So here I show you you can see there is a pie graph that is my time allocation. So in 2010, from 2010 to 2014, before the deep learning era, my research focused on statistical machine translation and traditional NLP. So my allocation would be like 40% to doing the coding, experiments with a data set, and I also do some paper reading. It's very essential to get to know the development of academia. And there are 20% that I need to spend on writing and also 10% for communication. Maybe some of you think that the communication is just, the time allocation is too small, right? That is because, back to 2010 and 2014, the natural language processing is not as much as popular as now, because back to then, everything was traditional. Okay. About my experience in industry, you can see that the time allocation is quite different. There are still like 40% of time doing some coding works, and there will be 30% of time allocation for the data analysis, which is running cycles, check assumptions, and also find some inspirations on very huge data set. And there is more communications because we have to have meetings with colleagues and other teams, like production team, operation team, and security team. Also, there's a specific engineering team to deploy our algorithm, our models. And I don't know, any of you here are students? Yeah, okay. So somehow if you work in the industry, especially which focus on development or research, there is a very typical career path like this. So we have a very small research unit or R&D unit. Usually there are 3 to 8 members. You can see on the bottom, right? 3 to 8 members, depends on your business. And after like 5 to 10 years, 1 or 2 members will grow up to the tech lead or supervisor. So each team will have 1 to 2 tech lead or 1 to 2 supervisor. So they have like 5 to 10 years experience in industry. And if you stay in the team for like 10 or 20 years, you can grow to be a general manager. You will supervise a huge team. There should be 1 or 2 or 3, or even sometimes 10 research units like this. You have to supervise. So that's a very typical career path in technology companies, like Tencent, like Alibaba, like ByteDance. Yeah. So they all have structure like this. So why do I talk about this career path? Because it's related to the somehow it's related to AI. Well, how do industry understand the AI? I would say that we have narrow perception of AI in industry. You can see before 2014, when we talk about AI, there will be like A-star search, robotics, like sci-fi. Okay, so those terms came to our mind when we talk about AI in industry. And after 2014, when we talk about AI, it would be highly likely deep learning appear to the brain of industry guys, right? And nowadays, especially after 2022, after the the publish of the ChatGPT, we have like when we talk about AI in industry, most likely it would be the large language models or the text to image models or text to video models. So I would say that somehow it's narrow percepted, right? So that we have something like the experience and the AI expertise paradox. You can see on the right bottom there is a curve. On the x-axis, it represents the length of the career of an industry guy. And you can see that the vertical axis represents the knowledge depth of AI. It shows that the professionals with longer industry experience tend to have less exposure to modern AI techniques and research trends. It's quite easy to understand that, right? Because AI is recently getting popular, and but somehow we can see that after the peak, there is a downtrend of like knowledge of depths of AI. Why this happens? Because that the education cannot chase the industry very fast, because we have a lot of courses that is not that tied to the modern AI techniques in industry. Yeah, we have to admit that our education has fallen behind these 3 years. So this gap can lead to challenges in adopting cutting-edge technologies or understanding their business value. So how do we make the curve going higher? That's the job of us, right? So somehow we can make the digital transformation faster and rapid in the future. Yeah. Okay. One of my observations is that the legacy system, outdated technologies, is still running. You can see that Elon Musk. Okay, here we see him again. We know that when he was in the Department of Doge, right? He said that the government is literally still running COBOL code, which is even older than the DOS, the oldest DOS system. Have you ever heard this coding language, COBOL? Yeah, so it's like 40 or more than 40 years old. So I would say that many industry systems still rely on outdated tools, frameworks, or non-AI methods, even in like the first-tier technology giants. And the technical debt and the infrastructure constraints often slow down the adoption of newer or more effective AI or deep learning-ready solutions. So what I see is that some experts, like when I was working in the Amazon, I was a supply chain analyst, and there are some logistic experts. They're still using Excel, and they refuse to use like intelligent tools to automatically optimize the routine, the transport routine. So I would say that this is a technical debt. So here, let's see the gaps between the academia and the industry. So this is a chart that shows the search trend of transformers. I think Dr. Wu has already shown you the transformers, but this transformers is not the movie transformers of movie. This is a neural network structure that published by Google in 2017. You can see that the trend from 2017 to now, this trend spent like almost 10 years, right? Almost 10 years. So what we can see from this chart is that the SOTA isn't always a priority in industry. So actually, why this happens? Because the performance is a major focus in academic research, right? So somehow when we publish paper, we will check it on some benchmarks and see if we achieve the SOTA. But it's often less critical in the industry settings. So in industry, we have to consider a lot of things like robustness, interpretability, scalability, and somehow whether or not this solution is easy to deploy into our existing infrastructure. So I would say that the SOTA is not equal to the industry value, but it's very important for academia. And sometimes the SOTA may be very minor. Overfit. The SOTA can be improvements may be very minor comparing to the existing solution. And somehow I would say that a lot of SOTA, they overfit to specific benchmarks. Even some some large language models we are using now, they have this issue as well. So, and the second is that the reproducibility and the transparency challenges, we have some challenges like this. Because when we see a SOTA in academia, we see that the implementation details are very likely to be unclear or omitted. So it will be very difficult to make the industry people to transit the academia SOTA into the industry practice. And sometimes we can see that there is poor documentation, and some papers, their results lack of open source. So this makes the translation of SOTA results, when we put it into industry practice, it's very difficult. And the performance of the academia doesn't always translate to industry practical. Here I will show you an example. Because I was coaching my students to participate in the AWS Deep Racer. I don't know whether any of you have heard the Deep Racer? No? Okay. So we know that there is self-driving cars, right? So the Deep Racer, to be simple, that the Deep Racer is basically a toy car with a camera in the front. So the race is in the track, you can see. And on the right-hand side, it's very it looks like the academia dataset. You can see that the track is rendered in virtual environment, and we will use reinforcement learning techniques to train our self-driving model. So you can see on the right-hand side, the background is clean, right? And the light is constant, but on the left-hand side, this is the input frame of the camera captured on the front camera in real track. So we can see that the background is not very clear, right? We have like boards, and we can also see that the lights will change when the little car travel on the different point on the track. So this is a gap that in the academia, everything is like clean and well organized, but in the industry, there will be a lot of like dirty works. So we have to talk about the novelty, right? So I think this term is very important to both academia and the industry. However, I think the academia and the industry treats this word very differently. When we introducing novel AI models into real-world business scenarios, so it's fraught with difficulties. Like I talked before in previous slides, that we have to consider scalability issues and also like some unforeseen complications. And the second is that sometimes it's very hard to ensure those models work reliably under all conditions, like the DeepSeek, the tool. I remember that when it was very popular last year, when I want to try some prompts in it, it doesn't respond at all. So yeah, that's a big issue. We know that the model is novel, but into industry, we want something else, more than just a novelty. And sometimes there is something called the stark reality of innovation, because in industry, we measure whether or not we want the novelty into our practice. We know that novelty is good, right? Especially now, we can see that the new academic result comes every week, right? So according to my own statistic, less than 3% of new initiatives actually yield positive results when measured against the business metrics. We know that in recommender system, there is a tool called A/B test. So I know that most of you use TikTok, right? So sometimes when TikTok publish a new feature, so like you can click the like, right? We know that the like is on the right hand side, but some of you maybe that button will move to the bottom. So there will be A group and B group, and the TikTok will monitor which group have better customer value. So that's a A/B test. So from my own experience in Tencent, less than 3% of the new ideas or novelty apply when we apply the novelty into practical, less than 3%, they gave positive results. So I would say that this low success rate underscores the importance of focusing on practical or proven solutions over on tested innovations. Still, it's because the different data set or different settings in the academia and industry. And the last of the point of novelty is that in industry we have to balancing with the practice. So we know that the innovation is very crucial, but if we think it longer, right? So it's crucial for longer term growth and the competitive advantage. It must be balanced with like pragmatic considerations to ensure the sustainable business value. So like the Dr. Wu has shown you a lot of tools that you can use DeepSeek models in it, right? So I don't know how many of these tools still working, still keep up with the newest DeepSeek model, or do they just keep the previous one? So all these problems we have to take into consideration. And the second is that we need to prioritizing robustness, otherwise you will lose your customer, right? And maintainability is also very important, and measurable improvements should guide the adoption of new technology. Yeah. So how do we measure? How to measure whether or not the novelty should be applied for the industry practice? We have something called the ROI. So the ROI refers to the return over investment. So what is investment? In industry, we have like three aspects to consider about. So the first is the human resource. We have to see how many man days or team hours we have to spend on application of the new AI or deep learning techniques. And the second is that we have, that the deep learning or the AI requires a lot of computation power. So we have to consider about the infrastructure costs like CPU or GPU hours. We also have to consider about the cloud bandwidth and storage. And last, that because I used to work in a recommender system, we have to consider about the user cost, because some like fancy deep learning techniques will potentially give negative impact of our user experience. So sometimes like when we deploy new model, the user latency is increased. Sometimes you may experience that when you browse TikTok videos, there are some lag, right? So we want to avoid improper cost of the users. Okay, so that is not to say that ROI is either good or bad. Yeah, it has pros and cons, right? So the pros be that the ROI will encourage fast-paced execution and prioritization of high-impact work. And often the result is quantifiable. It is very important in real work that you can quantify your work. And usually your work will be directly tied to the business KPIs, like how many users have increased to your product, and how many users still use your product after 3 months. And the cons are the first that usually the ROI can lead to short-term thinking, because we know that the big corporations or the industry, they make OKR or the KPI every 3 or 6 months. So when we talk about ROI, it can lead to short-term thinking. The leader will think whether or not we can finish this investment and get positive result during this term of the year. And second is that the ROI, may discourage innovations or investments in areas that are hard to quantify but strategically important. I would say that the language model is one of exception, because the open AI, they don't have to worry about the investment and the return. Yeah, so that's why the language models has brought us the AI revolution. Yeah. And I would say that there is also iteration speed gap between the academia and the industry. I don't know how many of you have used those tools, because I see there is an AI lab here. There's Microsoft and Huawei, right? So usually in academia, we don't have like integrated tools for us to deploy our latest deep learning models. But in industry, like Amazon, they have SageMaker, and in Microsoft Azure, they have the Azure machine learning platform, and in Alibaba they have Pi platform, and in Tencent we have Taiwan platform for the deployment of deep learning. You can very quickly, you can rapid translate from the concept to deployment with some lines of code. So from my own experience, once I saw a paper, if you want to translate the paper result into production, the quickest way to make it happen can be in hours, just in hours. So this agility allows for the very quick validation of ideas and the rapid feedback loops, which is very different to academia. We have to implement everything in academia. We have to code, we have to use like Python, Jupyter networks, we have to write PyTorch or TensorFlow code to deploy our deep learning models in academia. But in industry, we have all these integrated tools. And the iteration speed is also, we don't have to worry something like defect tolerance. We don't have to worry about some small issues. So I would say it's defect tolerance, and we have to we focus on practical. So sometimes we know that the industry data sets, we have a lot of dirty data. For example, in the user profile, some user may not to say that they are a male or female, right? So that is empty data, and some user they have like false birthday date, yeah. So in industry we have all these issues, but which is minor problem in academia. We don't have to worry about that. Okay, so so in industry the emphasis is on delivering functional solution quickly. Yeah, we want to do everything quick, not perfect. So in industry is that, but in academia, I think no one can accept your methodology, your procedure. If there is some problem, your paper would not be published, right? So in industry, we also have team pressure. I would say it's team pressure. We have to collaborative teamwork is very significant. And this also accelerates the iterations process, because we can, we can work as a team to solve the problem separately. And but I think in academia, most of the time, you will work on a specific task alone. And in industry, we have effective communication and coordination because it's very crucial to cooperate with other teams and other colleagues. Otherwise, you cannot achieve the career success. So, yeah, in industry, the model performance is very, very important because usually your product or your service are faced to the customer or users, thousands or even millions of users. So the model performance is very, very crucial. So despite the speed, the performance of models is very, somehow it's, I would say it's 1 volt. It's 1 volt. When I was working in Tencent as a researcher, we have very strict metric on the model performance that one recommendation should spend less than 300 milliseconds. Otherwise, the user will feel the lag between the videos. And the industry, yeah, we have to ensure the robustness and the scalability. Imagine that there is a new product, and after like months, the user can grow from 10,000 to million. So we have to ensure that the model or the deep learning algorithm is you can scale it up very quickly. So yeah, to wrap the ideas of gaps. So I would say that there are 4 major gaps between the academia and the industry. The first is the SOTA. It's not the industry priority, and the second is novelty. It drives recognition and not always the value. And the third is that the ROI rules the decisions. We have to consider the return and the investment and balance it. And the fourth is that we have to speed over the perfection. We have to either we have to fastly implement all our solutions, or we have to fail very quickly. Okay, so although I have observed those gaps between the academia and the industry, I have seen that the boundary between the academia and the industry is getting closer. So the number of papers from the industry surges in recent years, especially after the AI and ChatGPT. And some companies like ByteDance, Tencent, Alibaba, those tech giants, they have a special team that they have OKR, which is objective to measure their performance. They have OKR of like publishing papers. The more paper they publish, the more impact they will be in the industry. And second, that cooperation is very, very popular. There are more papers with authors from both academia and the industry. So what I can see is that a lot of students go to internship in big giants, and somehow they even hire people from the universities to do some research in their corporate. So back to our education. We have to talk about the talent expectation. So what does industry expect from talent? I don't know, any of you have idea that, okay, when you apply for a job, what do the company want from you? I will not answer the question very directly. Here I give you 3 cases from my own experience. So in daily works, you have to face some problem like if we have some videos, right? The videos are assigned with like low quality tags. And the second case that we want to model the user behavior history in recommendation, right? And the third case that fresh videos, like you just publish a video now, how do we assign the exposure to these new videos? So in industry, you have to face those problems concurrently, and there'll be no clear answer or no clear solution for your problem. So you have to solve those problems independently and concurrently. And you have to do a lot of things like analysis, yeah, and do some survey. And you also have to sometimes, in most cases, you have to implement and monitor your solution. And last, you have to verbose to announce that you have successfully solved the problem and assign credits to your team members. So. So there are a few abilities that is very important in working in industry, deep learning industry. You have to be a very good salesman. So you have to sell your point to others like, okay, I see a very good model, very novel model. I want to put this model into our existing solution. But you have to sell this point, you know, consider about the ROI and other aspects. And the second is that you have to be a very good storyteller. You have to, which is very similar to academia, you have to wrap your contributions into very good stories. I know that Elon Musk is a very good storyteller, right? So I think any students here, you should learn from Elon Musk, right? Tell a very good story. And the third is that you have to be a very good organizer because you have to work concurrently and independently. And you have to know which people is the right one you have to find for resources, for solution, or for help. So back to our teacher, I would say that it's hard to fill the gap, right? So from teaching to empowering may be the answer, or maybe the only answer. So you're in the traditional teaching, it produces like technically skilled students, right? We teach you how to use this, how to use that. But now in the AI era, I feel that it's not as important as before that we have to learn those very quickly, you know, those skills we can very quickly learn from AI, right? Sometimes we don't have to even use those tools ourselves. We can handle it to AI, right? So I would say that digital skills aren't just coding. Somehow we need a 3D model, which is technical tools. The second is methodological processes, and the last is cognitive business value awareness. I think it reminds me the Dr. Zhen's presentation that we have 4 stages of like digital transformation, right? So somehow it's kind of similar things. So yeah, I think the industry wants competence and adaptability because AI is evolving very fast. But I don't think we have already prepared for that. So that's why we have like a job mismatch, right? And those 3 words are from a sentence that I see somewhere. So the full sentence is that as vocational and tertiary education focuses heavily on job-specific skills, so less focus is given to competences and adaptability in using technology. So this has contributed to the job mismatch in the labor market. So I don't know, any of you see this sentence before? No? So this is from the Malaysian Digital Economy Blueprint, page 60. So I totally agree with this sentence, and I think somehow this sentence can guide us to make the digital transformation quicker and faster. So yeah, so that's all. Thanks everyone. And if you have any question, we can talk about it later.